Hey everyone, hello. Uh, good evening. I hope everyone had a great new year so far. I will be presenting a topic today, which is dynamic simulations using Pygame. My name is Robson. And yeah, let me get started with the presentation here. I have a quick self-introduction section here. This is me. You can also see me through the camera. I'm using a different PC for the camera because I'm on a personal computer here, so I don't have a camera here. But yeah, I'm Robson. This is my full name here. It's quite long. I am from Brazil. I am 22 years old. I'm located in Santa Inês, Maranhão, in Brazil. And my favorite hobby is to play games with friends. I usually spend most of my free time playing games. And I also love learning about software. And this expands to a lot of different areas in software. I love coding different languages. I'm currently really focusing on embedded software development. So this is currently the thing I'm focusing the most for software development. As per my studies, I am a technician in electroelectronics. I have completed this course during 2017 to 2019, and that was done in a technical school. I was doing this in parallel to my high school education. And I'm currently studying computer engineering in the IFMA. That's the institution that I currently am studying on. I should be finishing the course by not next year, this year, if everything goes right. And yep, I'm on the very end of my course here. As per career, I'm currently working as functional safety engineer at Forge, and I have been working here for the past 2 years. That's where met them, by the way. And I have been at Forge prior to that as well. I was working as what we call an EL researcher, and that is basically a defense role with similar to it's similar to how an intern works, but we use it to work a little more pending to software, even though functional safety isn't really software related. And this is actually my first job. So before that, I hadn't really worked with anything, but I used to participate in a lot of research projects during my high school and my university. And as per achievements, I really like to participate in any sort of competitions. So I have quite a few achievements that I got. Uh, at first, I had quite a few medals in mathematics Olympiads during my high school, and I have 10 medals in total. And I also included the greatest one here, which is a golden medal in the AIMO in 2018. That's the Asian International Mathematics Olympiad. And I participated in this Olympiad in 2018. It was in Thailand. And to this day, I believe that there are only 3 people in Brazil that got a golden medal, and I'm one of them. So yeah, it's very nice. I also participated in an exchange program to Japan in 2019. So I really love anime. I really love Japan culture. So it was really nice. Recently, I have also been pending a little more to the engineering side of competitions. So I participated in the programming marathon that we have here locally. It's the SBC marathon, programming marathon. And I got third place in 2022 and second place in 2024. And I also have been participating in some robotics competitions. I recently went to Greece to compete in a robotics competition there. You can find me on LinkedIn and also on GitHub. And yeah, in LinkedIn you can find me by name, and GitHub you have my nickname here. Okay, so let me talk a little about the project idea for these simulations. How did I get this idea? So basically, if we go back a few years when I was on the very beginning of my course, I'm not sure if this is true for every course in every country, but for engineering in Brazil specifically, we usually have some classes on physics on the beginning of the course. And this usually goes along with some practical classes as well. So we usually, in those practical classes, we usually take some laboratory experiments, and by the end, we should be creating lab reports for grading and that sort of thing. And even though the lab reports were kind of easy to do, I always found those reports kind of boring. So yeah, I used to really feel bored by just typing things in Word and just creating those reports. It was really, I always had a feeling that I could be doing something more productive during this time. And it was during this time that I was kind of going through an effort by myself to learn about Python. So I was doing some side projects at the time, and I kind of had an idea, why don't I replace those lab reports with software simulations? And that's when I got the idea. I was working with some games at the time. I was developing games just for my own learning on Pygame. And I got this idea of, hey, maybe I can use this to create physics simulation as well. And by doing that, I created those some of the simulations that I have here. I would show them by the end, but I created those simulations and I use it to present in the class. And instead of just delivering a lab report, which, as I said, it was kind of boring to do, instead of doing that, I would just present those simulations to the class. And I was explaining how I was able to create those simulations. And that was kind of the way that I was getting my grades on these classes. So right, it was very nice. And why use Pygame for this? So Pygame, uh, this library isn't really meant for physics simulations by itself. You can see the name, it's Pygame, it's meant for games. But I was working with Pygame at the time, and I really had the feeling that I could also use Pygame for this sort of project. And it is a library for creating games and multimedia applications. The cool thing about Pygame is it has a lot of functionality to create and display graphical elements. So basically, by just manipulating things that are showing on screen, I was able to create those sort of simulations that I'm going to show. And I was also learning Pygame by the time, this time, just by coincidence. As I said, I was kind of learning Python by myself, and I was doing some Pygame basic games to learn. So I was doing like chess or games like Snake and so on. And I had the idea of using that to creating those simulations as well. I'm going to very quickly show you how to set up Pygame. So I have those steps here. I can actually show that in practice. It's going to be a little easier. So basically, the only thing the special thing that you need to do is just install the library. You can do that by using the command pip install Pygame. If I just go into our project here, let me open the command prompt here. You can just type pip install Pygame. Of course, if you're using a virtual environment, you should activate the virtual environment first. And it is saying that I already have the Pygame installed here. So yeah, that's all you need to do to install Pygame. And after that, you can just create on your project a script that is going to import Pygame. I have this script here just for example, which is setup.py. I'm not sure if I can send at the end, but this is all in GitHub. So I guess it's good if you want to access this repository, you can find it on my GitHub. Maybe I'll send the link to you then. I'm not sure if we can send to the people here. But yeah, basically you need to have that installed and then import into a script here. So I just have import Pygame. This is also something that I like to do, another importation here for Pygame. I'm just importing everything from pygame.locals. It's going to help with some other comments down the line here. So I'm going to explain as we get there. But yeah, you just get into a script, you import Pygame, and then you do this pygame.init. This is basically going to initialize all of the functions for Pygame. After you initialize Pygame, you can just create a screen here, a display that you are going to be using for the project. And you can do that by using this command here, which is pygame.display.setMode. And then you configure the size of the screen, the width and the height. I'm using some other variables here, but you can just put the values directly here as well. And if you want, you can also set a caption here. I'm just typing here a simulation example. And for any sort of Pygame application, you should have a main loop running at all times. So as long as you have the screen showing up, you should be doing everything inside of this loop. I usually like to have a variable for that and then just have a while loop, because instead of the loop, we can just use another loop, which is using a for this time. And we can use this command here, pygame.event.get, to basically get any sort of interaction that we have with the Pygame screen. I can run the code very quickly here. And as you can see, this is going to just generate a blank screen. There's nothing here really. And this is by design. This is just a setup project. I'm not doing anything here. But I'm just going to show to you that you can kind of add event listeners here. So basically what you're going to do is you're going to check what is happening. So whenever you get an event, any sort of interaction is going to trigger an event. If you click with your mouse, or if you just type something on your keyboard, those are all going to trigger events. And you can just check what is the event type. So as you can see here, this is checking event type. This E here is the variable that I'm going to be using for the events. And I'm just checking if on this if condition here, I'm checking if I'm pressing quit. Can you hear me? Hello?
I can hear you now.
Okay.
Your sound dropped off for a second.
Oh, okay. Yeah, for some reason my headset has disconnected. But yeah, as I was saying, you can just get those if statements here and check if whatever is happening here. So in this condition here, I'm checking if I'm pressing quit, which is just closing the Pygame window, or if I'm pressing the escape button. And in this case, I'm just quitting Pygame and I just closing the window. And yeah, if I just click it here or just press escape, this is going to close. And I also put just another simple event here, which is I'm checking if I'm pressing the key A on my keyboard. And if I do that, I'm just reading A was pressed. I can also show to you, if I just press it here, it's showing here on the command prompt here on the terminal. So yeah, that's basically how we're going to set up our project. You're going to be adding more and more event listeners, and you can just keep on interacting with the Pygame screen that way. But how can you start adding things on the screen? How can we start drawing on the screen? And how can this be used for the simulations? That's for that. I'm going to be showing you some examples. On this first example here, it's going to be a very simple one. All of the scripts are on the repository again. So if you want to check out later, we can provide you the link. And this is just, I just added a few things on top of this previous setup script here. Now on this example one script. By the way, I'm not sure if this is good. Can you guys see the code well, or can you understand here?
Yeah, everything looks good.
Okay, nice, thanks. Okay, so uh, basically everything here is the same. I'm also creating the screen with specific sizes. I'm just using another variable for that. And what I'm doing here is I added two other event listeners here. I have another if statement here that is checking if I have pressed the mouse button. So this is the condition that I'm checking, mouse button down. And I'm checking which of the buttons is pressed. As I'm passing the index here, 0, this is checking for the left mouse button. And this one here, the index 2, is checking for the right mouse button. And basically what I'm going to do is, I have this command here, which is pygame.draw.circle. This is going to draw a circle on the screen. That's basically it. And I can kind of customize how this circle is going to look like by just providing the parameters here. So I can say where this circle should be drawn. I'm drawing it on the display, which is just the screen. This is the color code for the circle. Since this is all maxed out, it's just going to be a white circle. And I'm using the mouse position here to draw the circle. So this is going to draw a circle where my mouse is at. And this is just the circle radius here. And this is what I'm going to do if I press the left mouse button. And if I press the right mouse button, I'm going to do this other command here, which is pygame.display.flip. So the way that Pygame is going to show things on screen is we can keep on drawing more and more things, and they are not going to show by itself. So if you just draw whatever you want on the screen, it is not going to show already. What you need to do is you need to flip. Basically, the more and more things you keep on drawing, they are going to be kind of scheduled for the next frame. And when you do this flip command, it is going to generate that next frame, and it is going to show that frame on the screen. I'm going to show how this works on practice here. So as I said, if I click with my left mouse button, it's going to draw a circle. And if I click with my right mouse button, it's going to flip the screen. So how does it look like? So you cannot see that I'm clicking here, but I'm just left clicking here a few times, and you can see that nothing is happening. So Pygame is now drawing the circles, but they are not showing because I have not flipped the screen yet. So to flip the screen, I should click with the right mouse button. And when I do that, you can see all of the circles here. If I click with the mouse, with the right mouse again, this is going to just delete everything. So it's generating another frame, and it is just created on top of the previous frame. So it's just over everything that I have drawn before. And you can just keep on doing that. You draw whatever you want on the screen, and when you are done with the current frame, you can just flip, and this is going to bring everything that you have drawn to the screen here. And that's all well and good. You can just keep on adding more and more shapes. You can also use Pygame to load images and also use images here. But this is all static for now. How can we actually start by doing things dynamically? How can we make things move here? How can we add motion? That's what I'm going to show you on the next example here. Let me actually present the slides here. So yeah, for the example 2, I have a circle here, a ball here. And let's say that we want to simulate that this ball should fall. How can we simulate? How can we make this animation? for the ball falling. And to do that, we can just, overlap new frames, and each new frame can have a little increment on the position for the ball. And that's how we do animations, even on, on regular videos. We are also going to be doing that. We just create new frames, and each frame is going to have a slight change on the position of the objects, and that's going to create the notion of the movement of the object. I'm actually going to do that on the slides here. So I have 3 slides, and each slide has the ball in a different position. And as I'm passing through the slides, it looks like the ball is falling. It creates the notion that the ball is moving by just changing the position that the ball is at. But how can we do that on Pygame? To do that, we can just basically draw the circle and have it in a given position that we are going to be changing as the animation goes. So we can just calculate that position and be incrementing it as it goes. For this example here that I'm showing, the velocity is constant. So at each frame, we get a constant increment on position. So on the first one here, we have position 0. For the next frame, it is going to be moving in 10 units. So it's going to be the position 10. And then for the next one, it's going to be 20. And that's okay for simulation in which the movement is constant, the velocity is constant. But if we're going to simulate the ball dropping, we should account for gravity, and that's going to be actually accelerating the ball as it falls. How can we do that? We can just make an increment on both the position and the speed of the ball and the velocity of the ball. So let's say if the gravity is 10, as the animation is going, as the simulation is going here, we can just keep on adding that value onto the speed value. And then instead of just incrementing the position by a given amount, we increment the position by the speed value. So for example, we start at 0, position 0, and the speed is 10. As we go to the next frame, we just take this speed value and add that into the position. So we are now in 10. And the speed has incremented as well because, again, the gravity is accelerating. So the speed is now 20, which is 10, the previous value, plus 10. And then for the next frame, we just take the speed value and put that and add that into the position value. And now we go to 30. And the speed is also incrementing as well. So yeah, it goes to 10. And maybe that was not very clear, but I can just show you on the simulation here again. So I have this other script here. This is just building on top of the setup example again. I'm just adding a few more things here. So to calculate how the time affects the simulation, what we can do is we can create an event, a custom event, by using this clock thing here on Pygame. And we just say that whenever we get this timer that I'm passing here, which is this refresh rate, you can see that this is 50. This means 50 milliseconds. So whenever we get 50 milliseconds passing, we're going to get a new event. And we can just take that event, and each time we get this event trigger, we do something. So in this case, we are going to be generating each frame by every 50 milliseconds. And if we go here to the loop, we can just take the if condition for that. I'm checking if the event type is the update. And this variable here, the update variable, is the custom event that I created right here. So I'm just checking if we got this new event, which is the update, and it is going to be triggered every 50 milliseconds. And here, what I'm doing is I'm just writing the ball on the screen. This is another comment that you can use to write things on the screen, display.bleach. And it is going to be taking this current pause variable here. This current pause variable is what we keep on updating at every new frame. If you go here, there is this function, update variables, and it is just going to increment the current position by the speed value, and also increment the speed value by the gravity value. And we also need to consider the time as well, because since we're making updates at every 50 milliseconds, we need to say how much time passes between each frame. So let's see how that looks. You can see here on this screen, I have added a few things as well. You can see that there is a blue background now. There's also this green thing at the bottom here. It's supposed to be the ground. And the ball is on the position that I have set up on the beginning here. We have a variable, which is the starting position. It's 200. So it's going to be 200 pixels below the very top here. And when I click, the simulation starts to run and the ball starts dropping. It's actually going up because I forgot to mention that, but I can also set the starting speed as well. So if I say that the start speed is 0, it is going to be at a standstill. And when I run the simulation, it is just going to drop the ball. So it is dropping now. But I can also say that the initial speed is already a different value. If I say that it is 50, it is going to start by going faster to the bottom of the screen. And you can see it here. And if I put a negative value, it is actually going to be going up. So if I say minus 20, the ball is initially going to travel up and then fall down. And that value, all of the speed values, all of the position is calculated based on that function that I just said. And by the way, I'm not considering the ground for now. The ball is just dropping infinitely, but I'm going to take that into the next example. So yeah, basically for this example here, I'm just taking this function here, and it is just updating the position and the speed based on the functions that I have defined. So the speed is going to increment the position, the gravity is going to increment the speed, and that's it. And okay, let's go to the next one. I just put a note here as well that this is not completely accurate, because if we consider a real life example, the time between each frame also accounts. So that also needs to be accounted for. So this is not completely accurate. If we decrease the time between frames more and more, and then we make a simulation that has, I don't know, infinite frames, and then it is going to be the same as the real life. But as we cannot make looks like my headset is turning off for some reason. So uh, as I was saying, if we make infinite frames here, then this simulation is going to be accurate and exactly equal to the real life example, but we cannot do that. So the more and more frames we add, the more and more faster the frame rate we make, the more accurate it's going to be. But how can we maybe increment that without making that many frames? Because it is going to take a lot of computer power. How can we do that? And I'm just going to show that by going to another example. Let's say that we want to simulate a ball that is being thrown. Now we're also going to need to account for the ball movement on the horizontal. So the ball can also move side to side, and it can also move up and down. So it's going to have the whole plane of freedom of movement. And how can we take the actual formulas from physics to calculate the position of the ball? And I'm not sure if everyone here remembers, but we have those two formulas here, the formula for the position and the formula for the velocity. And we can actually apply those formulas exactly as they are on physics into this simulation. And the way that I'm using this approach for my example 3 here is I'm going to take the ball and calculate the velocity based on these two axes. That's actually how we do in physics. So, if I go into too much details on the formulas here, it's going to turn into a physics class, and I want to avoid that. But uh, we just need to consider the independent movement in the two axes. So we have the vertical axis that's going to be taking into account the gravity acceleration, for example, and we can calculate the position and the velocity at any times by just using these two formulas here. And the same thing to the side-to-side motion, to the horizontal movement. Although if we're throwing a ball, the ball is not going to be accelerating on the horizontal direction. So it's going to be a constant velocity here. And the way that I'm going to show you the solution here, the way that I have implemented it is I'm no longer going to be incrementing position or incrementing velocity. I'm no longer going to be doing that anymore. The way that I'm going to do the simulation is I'm going to increment the time. So for each frame, we're going to have the specific time at which it is currently at. And based on that time, we are going to be using those two formulas to calculate the position and the velocity. And that way, we can make an accurate simulation, and it's going to be similar to how it's going to be on real life. So every time we get a new frame, we're going to be updating the time value. It's going to be incrementing the time value. And we calculate the position and velocity, as I said, using those formulas. I'm also going to be taking care of collision now. If the ball hits the ground, it is going to be bouncing back up. And the way that I'm going to do that is I'm going to revert the speed, the velocity. So if the ball is going down, when it hits the ground, it is going to be moving upwards after that. And it is also going to be decreasing the velocity a little. I guess, let me just go to the example here. It's probably better. So this is on the script for the example 3 here. I also have a lot of customizable parameters here, but on the beginning, I'm just going to make a simple simulation. I also have a larger display right now. But basically, this is the position in which the ball is starting. For this first example, there is no starting velocity values, so the ball is just going to be at a standstill on this point, and if I run the simulation, the ball should just drop. And if I click it, you can see that the ball is now falling, and when it hits the ground, it is going to be bouncing back up. And if you notice, the ball is kind of losing momentum, so it's going, at every bounce, it is losing some of the velocity, so it's reaching less and less height here. It's going to be less and less high. And to do that, what I'm doing is I'm programming this value, this elasticity coefficient, and that's how much of the velocity is lost when the ball hits the ground. For now, this is 10, and I can actually change it. This is going to change how the simulation behaves as well. This is basically saying that the ball should lose 10% of its velocity when it hits the ground. And yeah, let me change it right now. I can say like 80. Now it's going to lose most of the velocity. And if you can see, it's bouncing way less this time. Let's also change some of the other parameters. There is also the velocity here. If I add a component on the horizontal, which is the first value here, the ball is also going to be moving side to side. So let's say that the ball is moving with 30 units of velocity on the beginning here. What that's going to do is, when I click the simulation, the ball is going to be moving to the side as well, along with bouncing, of course. And when the ball hits the side of the screen, what I made is it is going to just go to the other side. So that's, if it goes to the right, it comes back in the left here. And yeah, we can just go playing around with that. I can also put a negative value here. Let's also add a y-axis component here. Let's say the ball is moving up a little bit. So it's moving by 10 units upwards. And if I run that simulation now, you can see that the ball is moving up a little on the beginning there. And there's also, you can also use this parameter here that I have configured. And this is going to show what is the velocity values at all the times here. If you see now we have lines on the ball here, this is showing what is the current velocity on the ball. So since I said that it is going to have 30 units of velocity to the left here, because it is negative, and it is going to have 20 units of velocity to the upside, since this is negative as well, the ball starts by having some of the movement here. So yeah, to the left and to up. And when I run the simulation, the arrows are going to be adjusting based on the current velocity. So you can see that it accelerates a lot to the bottom, and then when it hits the ground, it is immediately changed the direction. And since all the formulas here are kind of set and they are correctly programmed, or so I hope, we can actually also change a few other things. For example, we can make the simulation go faster or go slower by just changing how much time changes between each frame. So if I say that now it is passing 500 milliseconds, the simulation should go faster. And that's going way faster now. I can also just make it way slower. Let's say 50 now. And yeah, it's kind of in slow motion now. And we can also say that the gravity is way larger this time. Let's say that the gravity is 50. It's 5 times greater. This should accelerate the ball downwards way faster. And you can see that it's accelerating a lot downstream here. And yeah, there are a lot of parameters that you can change here. I highly suggest that if you are able to test this code here, you can try by yourself. Let's also try something else here. Just remember, if I say that the elasticity coefficient is 0, that means the ball is never going to lose momentum. So the ball is going to be bouncing forever, and it's always going to be back up at the same height it started. So yeah, it's never going to lose, and it's just going to be bouncing forever. We can just also say that it is a negative value, and it is actually going to gain momentum when it hits the ground. And when I do that, it is going to be bouncing way higher after hitting the ground. And you can see that it is getting higher and higher here. And yep, again, I don't want to show into much details how the physics behind this is working, but it's actually very similar on the high level to the previous example. I'm just using the same event here, the update event, and on this event, I just draw everything on the screen. So I draw a frame here. It's just the background that you have on the simulation. I also draw the circle, and that is the ball that I'm using an example. I also have this condition here that is checking if I want to show the arrows or not. And then I just flip the screen and it's going to show the current frame. And after that, I just update variables the same way that I was doing before. It's just that the update variables is now a little more complex. And you can see here that it is taking all of the calculations that I showed before with those formulas here. And yeah, that's basically it for these examples. And the example that I'm showing here is actually something that I have prepared for this presentation specifically. I also wanted to show to you the actual simulations that I prepared before, that I created during my physics class. I think this one is nice. I have this one, which is basically, some of the text here is in Portuguese, by the way. I do not have time to translate it, but I have two examples here. This first one is showing a pendulum example. So you can see here that that's the pendulum. We have a string here and a little ball attached at the end. I have those two sliding bars here, and I can use that to move the initial position of the pendulum. So it's kind of tilted to the left now. And I have this button that I can click to start the simulation. When I click that, the pendulum starts moving. And there is also a lot of information here. For example, this is the frequency of the pendulum. So this is 0.7 hertz. And this is the period that it takes for the pendulum to complete the whole movement. And also there are energy values and velocity values here. And I can also change a few things here. I can make the string shorter by just moving this up. I can also move this again. And I also have a mass control here. I can make the mass larger. If you know about physics, you know that that is not going to change the frequency. Uh, yeah, sorry, my headset is turning off all the time. But yeah, if you know about physics, the mass is not going to change the frequency here, but it is going to change how the energy plays here. And I can also make the animation go in slow motion. If I click that, it goes way slower, but it's also showing everything here. So yeah, this is one of the examples, and that's for a pendulum example. I also have this one for a spring example. This is just a line here, but it's actually meant to be a spring. So what I can do is if I extend the string, it is going to be holding some tension there. And when I start the simulation, it's going to be bouncing up and down. And that's just simulating how a string is going to be working on this example here. And there are a few others as well. As we're reaching the time here, I can show you one more. I think this one is very nice as well. This is, if I'm not mistaken, this is the first simulation that I have created. So it's a little rough. But again, there is also some text in Portuguese, but this is just showing a column of water here. And we have some openings on the water recipient here. And this is going to create some water leaks. And this is simulating how, as the time goes, these strings of water are going to be behaving. And if I click, the simulation starts running, and the water jets just go way closer to the recipient as the time goes. And again, I'm using the actual physics formulas to calculate all of those examples that I just showed to you. And this is using some flow dynamics calculations to determine where the flow should be at. And I can also change some of the parameters here. But yeah, that's basically it that I wanted to show. I think we should be okay. Any questions so far?
Thanks so much, Robson. Any questions in the room or online? Question in the room was, are there any physics libraries that you can utilize that like help extend Pygame?
I think so. I have not worked with specific physics libraries. One thing that I wanted to kind of do while I was creating those projects is I wanted to kind of stimulate my logic thinking. So I wanted to really understand how those physics phenomena work. So for example, there's probably some library that helps with calculating the collision that I just showed on the first example. And that is really tough to do manually. It's really complicated, I'm not gonna lie. But I wanted to do that myself because I wanted to understand how we can create this sort of behavior. So the bouncing here when the ball hits the ground here, it's kind of complicated to do. Again, there's probably some sort of library that helps with that, but I wanted to try doing things manually by myself just to learn the logical thinking and be able to solve those sort of programming issues. Mhm.
Yeah, another one in the room. Robson, the question in the room was,
Mhm.
does Pygame also support like 3D visualization?
Yes, it does. I also have not worked with 3D on Pygame, but I know it does. It is basically a main library that you can use to create basic games, and that also includes 3D games. And I think things get a little more challenging when you are on 3D. But yeah, Pygame absolutely allows that. I highly recommend that if you want to learn about Pygame, there is a documentation for Pygame, the website, and you can find a lot of information there. It's very well documented. So yeah, that's going to help you.
I saw there's a question online from Paul. Hey, Paul. It says,
Mhm.
is the water pouring example from an equation, or do you simulate water droplets coming out of the tank like bouncing
Oh,
calls,
oh, that would be very
bouncing
complicated to do.
balls?
No, I'm actually using a formula there. We have, I don't remember what the formula name is, but there is a formula on flow dynamics that we can
Yep.
use for that. And it's basically going to be considering what is the pressure on the whole recipient. So each point is going to be to have some pressure value. And based on that pressure value, is going to be pulling the water with a certain velocity. And based on that velocity, I can just calculate what is the format of the water jet that is going to come out.
Looked like a nice way to visually understand the physics by being able to see it like that.
Yeah.
That's nice.
Mm-hmm. Nice.
Any other questions, anyone, for Robson? Yeah, so the question in the room was, where
Mm-hmm.
can we find the GitHub link? And Evan put it in the chat. So if you go to
Mm-hmm.
github.com/Rob TOG iGame Simulations.
Yep. Okay. Yeah. Thanks for sending the link. I can also provide it after I stop sharing here. But yeah, I also encourage you to kind of look through the repositories there. There are also the repositories for the other examples that I showed you. I have some examples on electromagnetism, on hydrodynamics, and also waves. So yeah, you can look at all the repositories there.
Great. Thanks so much, Robson. Any other questions, anyone? Or questions online? Great. Thanks, Evan. Evan's putting, and thanks so much, Evan, for co-hosting and managing the Zoom during the meeting. Evan's gonna put the GitHub link on the meetup site as well for the meeting, so it'll
Oh,
be there.
nice. Nice. Thanks, Evan.
Thank you so much, Robson. Yeah, that's a really great way to show physics visually and simulate things rather than the report. So yeah, I really
Yep.
like that. Thank you so much for going through that
Mm-hmm.
with everyone. I will.
Nice. And thanks so much for having me on the presentation here. I really liked showing. And yeah, I probably can find some other example to show to present again. I will contact you if I get any ideas.
Yeah, thanks, Robson.